So luckily we're back on the smart board. Today's homework is 138 to 142. Huh. Oh, it's that black thing over there. Yeah.
So, for today, is this the class that you record for today?
For today, it will be, yeah. Oh, okay. So, we are going to look at May, and that's the best that I can pronounce that name, I think it's May, and Samara. May has, what, Mai? Is it? Yeah, that's what I thought. So, people had issues with Mai this morning. They kept getting confused with, like M-Y, as opposed to, so that name is like Mai, but if, in your head, it's either Mai or May. My mom. So, let's document what we know. So, in your notes, please number, we're on 5-128. What do we know about May? How much does she have? We'll read the prompt. Stella?
She has one box of plasters.
May has one box, and Warren gave her 3 more pieces. So if we want to document what May has, we could say May has 1 box plus 3. So then go and look at how do we describe what Samara has. Check out all the important information in that problem. Just take a moment, dissect the problem on your own. How much does Samara have? Whenever I can find our cards. Iron, how much does Samara have? 3. Sorry, I scrolled a little past it, but it's in your info. Every group should have a book open, guys, because I do not keep this everywhere that you can, or like, I do not always keep this to where you can see it. What's Samara have? 6. How much does Samara have?
Oh, we were just...
Yeah, just getting your math book 10 minutes into class. Come on, guys. AJ, how much does Samara have? Oh, you don't have a math book either. Oh! Sorry, I had to. So, AJ, get a math book. So, Samara has 2 boxes. They're all many boxes. And then gave 6 to Will. So did she gain 6 or lose 6? She lost 6, so she has 2 boxes. Minus 6. So we could rewrite these by saying M is 1B plus 3. And S, if we say that Samara is going to be represented with S, is 2B minus 6. Please make sure you have this in your notes. We've set up an expression for Mai and Samara with how many cookies they have. A box and 3, or 2 boxes take away 6. Now the problem extends that to tell me what? Quentin, what's the next important information in the problem?
What page? 298.
298. Thank you very much. It's section 534. Like, we've been in these books the whole year. You know how to find it. What's the next important information? Well, that's the question, but what's it telling me next, Eliza? Now they have the same number. So what does that mean if we were to write it mathematically? they have the same number. What do we call that in math?
Equal.
They're equal. So we can say that my is equal to Samara. So we can set that up. But wait,
Wait, why?
we want to use our 5D process. So, Stella?
What are the 5Ds? I know what.
So on that paper, you have a couple handouts, but it's really like describe. Like describe what you have, which we've listed my and Samara, right? Describe or draw. You can also draw instead of the describe. Define. So we're kind of starting to define what we have. Then do, like test what we have. And declare. And there's another D, I forget which it is.
Decide?
Yeah, decide if it was right or not. So decide comes before declare. So like did what we did work? It's an awkward statement, but yeah. Like, was our test successful? Were we too low, too high, right on it? So that 5D process, we're going to make a quick one here. We're now going to set up our define section. We already know how many people are we working with here? 2. So our define section will be split into 2 columns. We have my and Samara. Now, we also know that we represented my with a box and 3 and 2 boxes minus 6 for Samara. Do we know how many cookies are in a box? We don't know right now. Nothing tells us. So we're also, and I apologize if you set this up really particularly, we also out here have to add in what we're guessing. Remember our trial? So we're going to guess values for B. So we're going to play with guess and check. How do we get them to have the same number of cookies? So let's guess a number for the cookies. Cam? 7. No, they're mini boxes. So I'm going to change colors because it's our first trial. Let's guess 7 for B. To figure out Mai's cookies, we know she has a box and 3 extra. So how many cookies would Mai have here?
A box of 10.
If a box is 7. In this situation, a box is 7. 10, right? 7 plus 3. She has 10. Yeah.
So the next one will be 14. If it's 20
Ooh,
minus
14, then minus 6.
Oh, I thought it'd be 20 minus. Oh, no.
Well,
sorry.
2 times B. B's 7 right
Yeah.
here.
Okay, yeah. I don't know why I thought each box was
So you're, what's 14 minus 6?
8.
8. So do Samara and Mai have the same number of cookies? So our decide here. They're not out you or you and your partner. Try another guess. We know 7 doesn't work, right? They're not equal. And we got an answer. Kind of hard to know whether this is too low or too high, because we're not shooting for a target number. We're shooting for them to be equal. So I don't know whether you should go up or down. Just try to shift one way or the other, see what happens. Try 14 if you want. Make B 14 and play that out. So guys, I tried 8, and I went from being 2 away to being 1 away. I got I got closer. AJ thinks that the answer is going to be 9. Let's try that. What's 9 plus 3?
12.
What's 2 times 9? Minus 6? 12. Yes, these are equal. So our final D in this process is our declaration of what we determined. What are we declaring? What did we figure out? Santi, what did we solve? What did we solve for here? I hear the connections you're making, but what did we solve mathematically here?
Oh yeah, we solved how we do the problem.
But what were we trying to solve for? That number that we got, 9, worked. It did what we wanted, but what's the point of it? What were we looking for?
The answer?
But what's the answer?
I don't know.
Sonny?
How many cookies are in a box?
We were trying to solve how many cookies in a box. So we have 9 cookies in a box. Do we have this in our notes? Once you do, move on to 129 and check out their 5D process that's already started for you. Figure out if we can solve that. Well, remember, we found out people were laughing about the concept. I'm writing on the board.
No, and why?
Why?
It says
no. It's no.
because I said so.
Because I said so. I'm just listening to you. You know what I barely know what I'm talking about. You barely know what I'm talking about. Yeah. Yeah.
So everybody look at 129 with me. I'm not too worried about how much you have in your notes right now. Alan's team is working on this problem. Eliza, why'd you just raise your hand? You got an observation? What do you mean you know the answer?
I mean, like, I know what
That's right.
goes in the question.
You know what goes in the question mark? What do you think goes in the question mark?
9.
You think 9? How does 9 go there if 9 went there?
Okay. Because the target is 36.
Okay. I know what you did, but it's not what we were supposed to do. What did Eliza do? You know, makes sense what she did? 9 makes sense on one way here, but it's not what we were supposed to do. You know why she got 9?
Because 4 times 9 would equal 36.
Ooh, 4 times 9 would equal 36. Now, if this was saying that the area was 36, Eliza, that's what you're thinking of, is if the area was 36. Now, area is not 36, perimeter is 36. What do they do in the do section? They have double of the one thing, double of the other thing. It says double each side and add together. Why? Why would we be doubling each side and adding together? If we have a length and a width. You with me, Aaron? We have a length and a width and 2 of each of them. Go on. Ooh, square. Rectangle. Ooh. What they're working with here is perimeter. So Ron says to get perimeter, you got to add up all the sides. And in a rectangle, we have 2 lengths and 2 widths. That's why they're doubling each side. Now, we just have one trial shown to us. Can anyone make a guess of how they figured out their width based off their length? Can you just see a connection up here? I'm not looking for right or wrong. I'm just curious if you can see a connection. Sonny?
I'm pretty sure it might be 10, but I couldn't be, I'm not sure because I'm just looking and because I'm looking up and down and I see 3 goes up by 1 and so that's why I thought
Okay.
9 goes up, but
I like that observation. If my length goes up by 1, does my width go up by 1? A question that I have is if your width is triple your length, is this width triple my... We don't know, guys. We don't know. This is not enough information.
I also saw that, but I was kind of more convinced by up and down.
Yeah.
Because
Well, and that's the thing. We don't know. Nobody told us what to do. We don't have enough information here to really work through this problem well. So, if we go to Alan's team, we're like, look, guys, we want to help you. You got to give us more information. They're like, oh, you might want to know this. So, Alan's teammate, Scott, gives us a bit more. He tells us that to find the width, we actually, look at the width down here. Did we triple the length to get our width? Who can describe what they did? Jeremy?
They multiplied the length by 2 and then added 3.
They multiply the length by 2, and then they add 3. So, the dangerous part about 129 is if we just dive into it and we don't kind of think critically, we're going to start solving a problem that we don't actually have all the details for. If we followed Sonny's method, we would think that the length of the last situation, the 4, matches with a width of 10. And we could have thought that was right. Mine, I would have thought it was 12. I could have thought that was right. We would have both been wrong. So, if we followed that method, Sonny, you would have been closer than I would. Well, we would have been equally close. We double the 4, we get 8, and then you add 3, we get 11 for the width, actually. So, I'm confused though. This expression down here, take a moment with your teammate. What is that expression doing? Like, what is that? What is that? Jesse, do you know what that expression is, highlighted in blue, what that represents? When you add up the sides of a shape, what is that? Perimeter. So here, our perimeter is expressed like this, because our length is x, and we have two of them, x and x. Our width, 2x plus 3, and we've got two widths. Any questions on what this is representing? That is taking your pieces of the shape and adding them up. So now, please write in your notes what's highlighted in blue right here. We want to review just really quickly, combining like terms, because I know some of us are struggling. So what's highlighted in blue, please write that out. And we could even say perimeter, if you want to relate this to this problem, is x plus x. You need to have a plus sign in there. Please get that written out. Now we're going to keep coming back to this skill, but while we were looking at it a little bit today, I wanted to make sure we talked about it. When we go to do the perimeter, we're asked to combine all of our like terms together to simplify. Two big pieces of vocab for this year. Like terms and simplify. Simplify is anytime I make things easier to deal with. I put a lot of stuff up here and put things together. So, first thing I want to ask, how many x's is this? Like, if I say Owen or Caitlin or Quentin.
Good afternoon. Please pardon the interruption. Just a reminder, if we have any 8th grade boys interested in Cardinals baseball this year, please stop by the office to let me know so I can include your name with an email message. Again, 8th grade boys interested in Cardinals baseball, please stop at the office today. We also have our PTSA Dine to Donate at Piata today at the Piata Worthington location. And we still have many items left from our international feast, so please stop by the table to pick up any items that you might have brought. There are a couple of items that are labeled out there. So Stella Campbell and Sunny Nutter, please make sure you pick up your items as well. Thank you.
Well, it's because they brought stuff for International Feast. All right, Quentin, what number could I put in front of this X? A 1. Please do that in your notes if you didn't already. And here, there would also be a 1 in front of the X. If I just say Austin, you know I'm talking about 1 Austin. I don't have to say 1 Austin. So if you just say X, we know you're talking about 1X. Now, here's where people want to screw it up. Give me your eyes. This is where everybody wants, like, you're going to try to make a mistake here, I guarantee. These variables represent things, right? They represent objects. Here, like a width. Well, let's say they represent a marker. If I have 1 marker plus 1 marker plus 2 markers, are these markers? No, so I can't add those in because my x's are markers. So I got 2 markers here. Forget about that guy for now. Plus another 2 markers. How many total markers in my problem? 6. This becomes 6x. And I'm going to highlight that to make it obvious. These are like terms because they have the same variable, that x. What other like terms do I have up here? Caitlin? 3 and the other 3 can be added together, so we get plus 6. Now, this next part of this process, I don't need you to completely understand, but I want to expose you to it. The more you see it, the more comfortable you'll be with it. So please just write down and follow as we go. We're going to do this kind of quickly because we want to move on to another problem. They tell us that our perimeter is equal to 36. We could really easily solve this problem if we know how to work with algebra. Now, we don't have to be good at this yet. By the end of the year, you'll be a whole lot better. If I wanted to get my value for what x is, right, I want to solve that. First thing I need to do is combine like terms or get rid of terms that aren't useful. If I'm trying to solve for the x, I don't need these 6 over here. I want to solve for this x, so get rid of this 6. How do I get rid of a positive 6? Yeah. Subtract it from both sides. Please write that out in your notes. Show the minus 6 on both sides. Leave space. Then rewrite that. Now on the left side, I just have 6 times my x equals 30. If I have 6 times of what I want, what do I need to do to get what I want? Divide by 6. You're writing this out with us, AJ? I love that you know what you're doing, but I need you to have it written out. And that would tell me my width is 5. This, and Jesse was just talking about, like, or a couple of you have talked to me about, it seems like the 5D process, like, takes a long time. It's a lot to write out, a lot to do. This is what we're working towards. This is more efficient. It's quicker. And once you understand it, it's easier. And once you understand it, I don't expect you to think it's easy right now. Jesse?
Yeah, I don't.
It's fine.
I don't understand the 6x plus 6 because that equals.
Essentially, you have 6 of the chunks that were the width, because that's what x represents, is the width. So if you think lengths, you have 6 of those chunks plus 6 1 pieces. Now the x pieces, you don't actually know how long they are. The 1 pieces, you do know how long they are. The whole thing makes 36. So if we were to draw this as a picture, we would have gotten a line that is 36 that we could break up with 1, 2, 3, 4, 5, 6. If these are all 1 pieces, and then this section would have 6 x's, so there'd be like x and x and x, and I'd have to make it show 6 x's. But if these are 6 1 pieces, and then I can chop that off, well, this chunk over here would only be 30. We'll do more with this. Okay, I'm trying to quickly explain something that you don't have to understand right now. Can you just do me a favor and not be stressed out that you don't understand it? Because I've told you multiple times you don't need to understand it right now. Like, just start to get familiar with it. We'll cycle back to this. Sonny?
Also, you left the answer to that problem on the board, on your chalkboard.
Yeah, I mean, that is the process.
Yeah.
Because earlier I didn't have a smart board. So, Izzy's team is looking at consecutive integers. So I need you guys to quickly kind of copy this table down. Now, you don't have to write out all the words, but what I want you to copy down, I'll do it with you as we go, is the define. And we're going to split that up into 3 sections. So first number, second number, third number. Then the do is going to be add them all up. And the decide that we want is that it will sum to 57. Now what we're working with here is called consecutive integers, and that just means one right after the next. So 5, 6, 7, 8, those are consecutive because one comes right after the next. They tried 15, so then their next number would be the next number. What would that be? 16, and the next number is the next number. 17. So then they add all those up, 15, 16, 17, and they got 48.
It's not big enough.
Not big enough. Then they tried 20. You made that noise. It's not funny. 20, the next number was, they add those up. Did they get what they wanted? Too big. So wait, if we tried something and we were too small, tried something we were too big, what does that tell me I should try next? Row on. Something between them. And thank you for controlling it. AJ wanted to say try 17. So I make my first number. Make your first number 17. What would the next number after that be? 18. What would the next number after that be? 19. We add them all together. Sorry, 17 plus 18 plus 19.
But I made the same mistake. I'm not even
17 and 18 kind of make a pair. Whenever you see a 7 and an 8, 7 and 8 make 15. Right? They kind of pair up. So these together make 35, 45, 54. We're going for 57. Did we get there? No. Too small, too big. Too small. Well, not way too small. Just still too small, right? Like not too far away.
It's not so tiny.
What about 17.5?
Ah, now, thank you for asking. They're working with integers. Remember, integers don't have the decimal. Integers are entire numbers. Sonny?
It would have to be either 19 or 18.
Yeah, so let's just keep stepping up. Let's try 18 for my first number. So if 18 is my first number, what's my next one? What's my next one? We add those up. What does that give us? Iron?
57.
Is that what we wanted?
Yep.
Questions on that one? Last one I want to look at just really briefly. Are we good here? Do I need to wait? Marbles. Miko saw an expression and he felt like he could probably work it backwards. So this is a challenge. Miko's friend already started the 5D table. He wrote out these expressions comparing red to green and comparing blue to green. My challenge for you is in the next 2 minutes that we have with class left, if there are 15 green marbles, can you figure out how many red there are and how many blue there are? And then how many total? He's shooting for 71. If you can figure that out for 15, try another trial. Take a moment, try this on your own. How many green, how many blue? We got about 45 seconds left. Let's start doing this. If there are 15 green marbles, then Kaylee, how many red?
Good afternoon. At our afternoon break, if I could please have Wyatt
I realize that I
Forsythe
looked
and
around.
Peter Howe to the office. Wyatt Forsythe and Peter Howe.
Austin, how many red?
Thank you.
13, right? Because if there's 15 green, we take away 2. If there are 15 green, how many blue? Santi?
What?
Not with me? Wyatt, you with me? How many blue?
12. No, 11.
Calm yourself. You're trying to jump at it. Kimberly? Double the greens, then add 5. So we double the green, and then add 5. So we're going to keep working these processes. Have a great day.
What? Okay.
You see what you got.
Well, I guess I gotta go. I don't know, probably.
Yeah, you said mass count. Mass does count. It does count. Yeah, but what are you worried about? You don't need to get that number checked. All because you're behind. Like, do you have anything for math in math?